Section 6.2, we're going to be solving right triangles. We did this a little bit the other day. Now notice the standard notation here. We see it clearly in problem 2. Typically, for lengths of sides, we use little letters, and for angles, we use big letters. And the standard thing is C is always the right angle, and C is always the hypotenuse. And then A and B really doesn't matter, but if this is angle A, opposite of angle A is always side A. And opposite of angle B is always side B. And so that's the standard thing. So a lot of times I'm not going to give you the picture. I'm just going to expect you to know that. All right, so let's take a look at number 1 here. Number 1, we're given this angle is 26.7 degrees, and that length is 0.17. And we wish to solve the triangle, which simply means we want to find the value of all the other things, all the missing pieces. What would you do? I think you could quickly find the other angle. Angle T is 90 degrees minus 26.7 degrees. What you told me is 63.3 degrees. Okay, very good. And how about, which one do you want to find next? Do you want to find little s or little t? Little t, okay. What would you do to find little t? Tangent. So you would say tangent of 26.7 degrees is opposite over adjacent, so that's 0.17 over little t. Multiply both sides by t. T is, or t times tangent 26.7 degrees is 0.17. So to get t, we would divide. I'm going to grab my calculator. 0.17 divided by tangent of 26.7. I get 0.34 rounded to 2 decimal places. Why did I choose to round to 2 decimal places? The directions didn't tell me that.
Because the other side was rounded to 2 decimals.
Because the other side was rounded to 2 decimals. So if the given side is rounded to 2 decimals, it made sense to me to round that one to 2 decimals also. All right, finally, how about little s? Sine. Okay, so I would say sine of 26.7 degrees is opposite, which is 0.17 over s. How come we didn't just use the Pythagorean theorem? Because we rounded. And again, in general, we don't want to use numbers that we figured out. And we really don't want to use numbers that we rounded. So you're better off going back. S would be 0.17 divided by sine 26.7 degrees. 0.17 divided by sine 26.7 degrees is 0.38. Questions on that one? All right, down to number 2. Number 2, we're told A is 12.5 and B is 18.3. How would you solve that right triangle? Pythagorean theorem. This time Pythagorean theorem does make sense. I'm given both A and B, so I can use that to figure out C. 12.5 squared plus 18.3 squared equals C squared. So C is, mostly this is calculator work here, 12.5 squared plus 18.3 squared. I got 491.14. I take the square root of that answer. 22.2 2. And again, I'm going to round to 1 decimal place because the given information was rounded to 1 decimal place. Okay, how about the angles? Let's find angle A first. How would you find angle A? Tangent, because I have opposite and adjacent. Those were the given pieces of information. Opposite and adjacent uses tangent. So tangent of A is 12.5 divided by 18.3. So A is going to be tangent inverse of that value. And again, I grab my calculator. Tangent inverse of 12.5 divided by 18.3. I get 34.3 degrees. Almost done. How about angle B now? Okay, I could go 180 degrees minus 90 degrees minus 34.3 degrees. Slightly risky, but not terribly risky. Why is it slightly risky? It is a rounded number, and it is something we figured out. So it comes down to how confident are you in that answer. I'm pretty darn confident, so I think I'm okay here. I get 55.7 degrees. What would be the other way I could find angle B? I could use tangent again, couldn't I? Except I would have tangent of B. What would tangent of B be? 18.3 over 12.5, because for B, this is opposite, this is adjacent. So I could do it the same way I found A. Let's just make sure we get the same answer. Tangent inverse of 18.3 divided by 12.5. I do get 55.7 degrees still. Questions on that? All right, in the interest of time, I'm going to skip part B there. Part B is very similar to what we did in problem 1. What we're going to use solving right triangles for is all sorts of word problems. For example, the angle of depression of a television tower to a point on the ground 36 meters from the bottom of the tower is 29.5 degrees. Find the height of the tower. Now, you need to be a little bit careful when you see the words angle of depression or angle of inclination. What do those words mean?
Depression means a negative rotation.
Typically, yes. Typically, angle of depression is a negative rotation, and we'll talk about positive angles and negative angles here in the next section, I believe. But more importantly, if I didn't give you this picture, a lot of people will draw the picture and they'll draw this angle right here as 29.5 degrees. And that's not correct. That's not the angle of depression. Angle of depression or angle of inclination means the angle from horizontal. So here's the horizontal. This is the angle of depression. This angle is not being measured from a horizontal, it's being measured from a vertical. So that's not angle of depression. So the angle that I gave you, the 29.5 degrees, is not really the angle that you need for this problem. What angle do you need for this problem? You need this angle, which is 60.5. It's the complementary angle. It's 90 minus 29.5, which is 60.5. So be careful of that. If I give you the picture, it's not really a big deal. If I don't give you the picture, then that's when a lot of people will mess up. A lot of people will mark that angle incorrectly. Okay, what am I trying to find here? The height of the tower, which is over here. I'll call that H for height. Well, with the information that I have, what can I do to find the height of that tower? Well, I have an angle, and this side would be the cosine. Cosine, I don't think would help, because what does cosine use? Cosine uses adjacent and the hypotenuse. Unfortunately, I don't know the length of the hypotenuse, do I? You're right. We need to use tangent. That's okay. Easy mistake to make. We need to use tangent because this is our angle. We know information about opposite, and we're trying to find information about adjacent. So that's tangent. Okay, so you really need to look at your picture. Your picture tells you which of the functions you should use. In this case, we can't use sine or cosine because we don't know the length of hypotenuse. I think we need tangent of 60.5 degrees is 36 over h. I multiply h times tangent 60.5 degrees is 36, which means h is 36 divided by tangent 60.5 degrees. I grab my calculator. 36 divided by tangent 60.5 degrees. I would go with, I got 20.36. So what should I call it? 20.4. Why 20.4? Meters. How come we chose to round off to one decimal place? Because again, they did. They wrote it as 36.0, which means they rounded off to one decimal place, so we round our answer to one decimal place. Questions on that one? Number 4 has the angle of elevation from a point 32.3 feet from the base of a tower to the top of the tower is 38 degrees 20 minutes. Find the height of a tower. What do you do? Draw a picture. Okay. So here's the tower. And I know I'm 93.2 feet away from the base of the tower. I can draw that, I suppose. I'm assuming that it's not the Leaning Tower of Pisa. I'm assuming it's a tower that goes straight up and down. Where's the angle of elevation?
At the point where you are.
Yeah. We go from the horizontal. Here's the horizontal. The angle of elevation would be that angle right there. So we're told that angle is 38 degrees 20 minutes. What am I trying to find? The height. So again, I'll call it h for height. What do I do? Which of the trig functions should I use? It looks like tangent again, doesn't it? Because I've got my angle. This is opposite. This is adjacent. That's tangent. So tangent 38 degrees 20 minutes equals h over 93.2. H is, I grab my calculator, 93.2 times tangent 38 angle degrees, 20 into angle to get the minutes, is 73.7.
Did you get degrees again?
How did I get degrees? I went 93.2 times tangent 38, and you get the angle button here on apps. So I went second angle. The first one is degrees, and then 20, and then into this angle thing again. Second angle minutes. I typed it in that way. What would your other option be? Convert it to a decimal. So what's 20 divided by 60? 0.3333, and it goes forever. So that's not great, because then you do have to round that off a little bit to type it in, but you'll get an accurate enough answer, I think. Questions on that? All right, so on number 5, when they say the length of the escalator, they mean that. How long, oops, you can't see my picture. How long the escalator is when you're riding on it, not how far it goes horizontally. And then the vertical distance, we're told, was 59.7 meters. So, what function should I use to find that angle theta? Sine, because I now have opposite and hypotenuse. So sine theta is 59.7 divided by 330.7. I grab my calculator using the sine inverse button. Sine inverse of 59.7 divided by 330.7 is 10.4 degrees. Is that the answer you had?
10.2.
10.2. It comes out close, doesn't it?
I think it's just done.
So when you're solving for when you're using trigonometric function equations like that, you're using the inverse whenever you're looking to find the other angle.
If you're trying to find an angle, then yes, you're always going to use an inverse. So to get rid of this sine, the opposite of sine is sine inverse. And that is interesting that if you marked this as 330.7 and use tangent, you ended up with 10.2, which is really close. Not quite the right answer. Okay. Find the angle of elevation of the sun if a 48.6 foot flagpole casts a shadow 63.1 feet long. Well, here's our angle theta. This time they gave us the picture. It's always nice when they give you a picture. What do we know? The opposite and the adjacent. So we're going to use tangent. So we're going to have tangent of theta is 48.6 divided by 63.1. I want the angle theta, so if I want the angle theta, that means I use the inverse, so tan inverse of 48.6 divided by 63.1 is 37.6. More than one person says so I'll believe you. 37.6 degrees. All right, before I do problem 7 is a little bit different. These examples are all okay, I suppose. Nothing earth-shattering here. Can anybody give me an example where you might actually use this in your real life?
Well,
Architects use it quite a bit, that's true.
Oh, rocket science, literally.
Rocket science, maybe? A few years ago, I used right triangle trigonometry for something, and here was the deal. My house sits about like this. My house, if I'm looking from the top, my house kind of has that shape. And there's a fence here, and along this fence there's a bunch of trees. And then over here is my neighbor's garage. This tree was dead, and I didn't want it to fall. I didn't want it to fall and hit my neighbor's garage or hit and smash the fence, or worst case scenario, fall and hit my house. So I wanted to cut that tree down. What's the only direction I can make that tree fall? The only direction it can go is towards my house. And what was I worried about? I was worried about if I cut that tree down and make it fall that way, is it going to hit my house? So what did I do?
Probably want to angle it to the little corner there.
Well, I couldn't really make it fall this way because the branches of these trees stuck way out. These are big trees. It would have hung up in the other trees. I did not want to make it fall on my neighbor's house. I didn't want to pay the insurance bill. The fence wouldn't have been too bad. That I could have fixed. What I did is, here was the tree. I walked back here and I measured. I measured how far that was. I'm going to make up I don't remember how far it was. I'm going to make up a number. Let's say this was 72 feet. And then I got a protractor out. And I measured that angle. And again, I don't remember what the numbers were. Let's say this angle turned out to be 32 degrees. What can I then do? I said 72 degrees when I meant 72 feet, yes. So what do? I solve. What function did I use? Tangent of 32 degrees was h over 72. So h was 72 times tangent 32, 44.99 feet. So I definitely had enough room. So actually my numbers are wrong because the way it came, this must have been shorter or this must have been bigger. Because the way it came out, according to my approximation, this tree should fall and it should miss my house by 5 feet. I wasn't willing to take the chance, so I hired somebody to professionally do it, climb the tree and trim the branches and top it off. I wasn't willing to take the chance and do it myself.
I personally would have just cut it in sections, honestly.
Yeah, but to cut it in sections, you got to climb the tree. I didn't want to climb the tree. So that's what I ended up doing, is I ended up hiring somebody to professionally come and knock that tree down. Anyway, there are lots of very simple examples of that where right triangle trigonometry is used. And that was one for me personally. So I reversed those numbers somehow when I just made up numbers here. But that's what happened. A real example. All right. Number 7. A weather balloon is directly west of 2 observing stations that are 10 miles apart. The angles of elevation from the balloon to the 2 stations are 17.6 degrees and 78.2 degrees. How high is the balloon? Okay, so we have 2 observing stations. And what do we know about these 2 observing stations? They're 10 miles. And then we have a weather balloon up here in the air. And I know the angles of elevation. So I know this angle is 78.2. And this one must be the shorter one, 17.6. How high is the balloon? H. All right, so I'm going to assume that's a 90-degree angle right there, yep. do you do?
Would you do like each triangle separately?
Yeah, I kind of have to do each triangle separately. And there's another problem. I don't know this distance, do I? Turns out we don't need to know it, but we need to give it a letter so that we can call it something. What do you want to call it? X.
You
All right.
gotta solve the one triangle first before something.
Yeah, we're going to kind of solve them both together,
That's why I
actually.
get the distance of it.
Yep. All right, so
10 miles.
if I'm looking at this triangle right here, I could say tangent of 78.2 degrees is h over x, opposite over adjacent. But what about if I'm looking at the big triangle? What would I have? Yeah, my adjacent side is going to be x plus 10. So on this triangle, I'm going to have tangent of this angle, 17.6 degrees, is opposite, which is h, divided by this whole distance, 10 plus x. So I end up with two equations, but they both have two variables. How do I solve something that has two equations with two variables?
Set it equal to x, basically, and then solve
So what you're saying is I can take this first one
x equals then.
and get x equals. Okay, so I would multiply, I would have x tangent 78.2 degrees equals h. So x is tangent 78.2 degree. No, I'm sorry. I have to divide here. I divide both sides by this tangent thing. So x is h over tangent 78.2 degrees. And then I can take that and plug it in right there, can't I? That gives us tangent 17.6 degrees equals h over 10 plus h over 78.2 degrees. Well, that looks promising. Don't let this too confuse you here. That's just the page number. What's that? Oh, I need tangent on the bottom. Yes, thank you. Well, the good news is we now have an equation, and the equation only has one letter. It only has the letter h. But it's not a very easy equation to solve now, is it? How would you solve that equation? Common denominator? Yeah, common denominator is a pretty ugly thing because it's tangent 78.2 degrees. I could do that. Any other good ideas? Cross multiply. All right. So think of, I like that idea. This is one big fraction here, and think of this as over 1. So I can cross multiply. I take this top and cross multiply it with that bottom, and then I take this bottom and multiply it with that top. So that's going to give me h equals tangent 17.6 degrees times 10 plus h over tangent 78.2 degrees. Well, that's an improvement. Fewer fractions. That's always a good thing. Now what? Distribute. Okay. So h equals 10 tangent 17.6 degrees plus h tangent 17.6 degrees over tangent 78.2 degrees. We're getting close. Next good idea? Well, I think it's time to grab my calculator and just figure out what this fraction is. So I'm going to have h equals 10 tangent 17.6 degrees plus, I'm going to take tangent 17.6 and divide by tangent 78.2, and I get 0.066h. Rounding off to 3 decimal places is probably plenty. All right, well, from here now, I think it's pretty easy to solve. How do I solve now? Eventually, I'll do the tangent times 10. But what am I going to do with these h's here? Move this one over. So I'm going to subtract the 0.066h on both sides. So 1 minus 0.066 is 0.934. H is 10 tangent 17.6 degrees. So H is 10 tangent 17.6 divided by 0.934. Calculator says 3.4 miles. That balloon is 3.4 miles in the air. All right, so that last one, drawing the picture and setting it up isn't too hard. The algebra involved to solve that one is a real pain in the neck. So watch out for those. There are some of those in the homework.